In this demo, we'll implement the observer pattern. And we're going to start with a helper class, ticket change. This will hold the state change information that needs to be sent to observers. For example, a ticket change for artist with ID 1 and amount 2 means that 2 tickets have been sold for this artist. It's an object of this type that will be received by observers. Then let's add a subject. That is our ticket change notifier. It's an abstract class. We don't want it to be used on its own because it doesn't contain the state information observers want to be notified about. That is contained in the concrete implementation. What this does contain is a list of observers, and those are objects that implement iTicketChangeListener. We haven't defined that interface yet, so let's do that next. Like that, our code will resolve again. And there we go. It's named iTicketChangeListener, and this is our observer. It contains just one method, receiveTicketChangeNotification, which is used by the subject to notify its observers about a change in the amount of tickets. Then we can start adding methods on our ticket change notifier. We need a few methods to manage observers. After all, it is the ticket change notifier that needs to keep a list of observers it needs to notify. So we call into addObserver, which accepts an iTicketChangeListener as parameter. When the method is executed, the observer gets added to the list of observers. RemoveObserver removes an observer from the list. And when notify is called, all observers receive a ticket change notification with the ticket change object passed through as parameter. That's it for the abstract class. On to the concrete implementations. Our subject is the ticket change notifier, and we're going to start with the concrete subject, which is our order service. It subclasses the subject, the ticket change notifier. What this class is concerned with is its state. For all registration and communication related tasks, it relies on its base class, the ticket change notifier. We're going to add one method to it, complete ticket sale. It's this method that is called by clients when a ticket sale is completed. That means that at this moment, the order service must update its state. It must update its data store so the correct amount of tickets for the correct artist is deducted. For demo purposes, we'll assume that when we see an order service is changing its state message, that the local data store is adjusted. After that, it calls the notify method on its base class, the ticket change notifier, to notify the observers. And with that, we've got our concrete subject. The last two parts of the pattern are the two concrete observers. The ticket reseller service is our first one. It needs to implement the iTicketChangeListener interface. That forces us to implement the receiveTicketChangeNotification method. This gets a state change from the concrete subject passed in, and that is the ticket change object. Thanks to the info it gets from that object, it can adjust its own data store accordingly. Our last concrete observer was the ticket stock service. This too receives a ticket change notification, allowing it to update its data store. And that's it for the pattern implementation. Now let's write a bit of code to test this. First of all, we new up our 3 services. For that, we need to import the observer namespace. So we've got our 2 concrete observers and we've got our concrete subject. To that concrete subject, we add these 2 observers. For that, we can call addObserver on the order service. As a parameter to addObserver, we need to pass through something that implements iTicketChangeListener, and both our ticket stock service and ticket reseller service do. Then let's say that a ticket sale happens for the artist with ID 1. Registering such a ticket sale on the order service means calling the complete ticket sale method, passing through 1 as ID for the artist and 2 as the amount of tickets. This call should result in both observers being notified of this. Let's give that a try. Let me just add a read key statement here, and there we go. And that seems to work just fine. Order service is changing its state, after which it is notifying its observers. And then we see messages from our observers who are being notified of the ticket change. So far, so good. The nice thing here is that we can manage all of this at runtime. We added the observers at runtime. That means we can also remove them. So we remove one observer, the ticket reseller service, and then we complete another ticket sale. Let me add a console.writeLine statement here. That makes it a bit more readable. And let's give this another try. And there we go. The first 4 lines being written out to the console output window remain the same. After that, the ticket reseller service observer is removed, and that results in only the ticket stock service being notified of the new ticket sale. And with that, we have successfully implemented the observer pattern. Let's have a look at some use cases for it.